Okay. Question 226. Sodium hypochlorite, NaOCl, is the active ingredient in pool chlorine. It completely dissolves in water to produce the hypochlorite ion, OCl-, which undergoes hydrolysis according to the following equation, or equilibrium. The equilibrium constant for this reaction is 3.33 by 10 to the minus 7. For pool chlorine to be effective, the pH is maintained by a different buffer, and the hypochlorous acid HOCl should be 1.3 by 10 to the minus 4. Calculate the volume of 2 molar sodium hypochlorite solution that needs to be added to a 1 by 10 to the 4 liter pool to meet the required conditions. Okay. This is a module 6 question. It's about buffers and you've got hydroxides. Yeah, so it's a base. However, it's mostly just a module 6 context. Because you've got double arrows, it is mostly a module 5 sort of ice table-y kind of question. All right. Now, there's a few different things going on here, so it's kind of awkward or kind of difficult for us to figure out where to start. The first thing I need to mention to you is this. Yeah. What you normally do when you're starting things is you write the balanced chemical equation, you kind of figure out what's happening. That's one thing I have to mention. You are very U-S-E-D, not used. You are very used to writing dissociation equations for neutral molecules at the start. Yeah. What you're very used to is this. HOCl is a neutral molecule. It has no charge. You're very used to starting off with that and then going plus H2O and then OCl minus and then plus H0 plus. Yeah, that's what you're used to. Okay. There is nothing wrong with starting with anything on the left-hand side of your equation. It's just that you're used to the thing with no charge on the left. And when you're doing acid-base equations in module 6, you're very used to seeing all of the charge on the right. Okay. The first thing I need to mention to you is this. With these kinds of questions where they're context-based and they give you like a real life situation and it's not just, oh, calculate the pH of this or calculate the volume of this beaker. This is a, I don't know, swimming pool with chlorine in it. All right. Guys, I need you to keep in mind that go back to your foundations. Yeah, it's not always, it's not, don't think of it as acid dissociating or base dissociating. Guys, what the reagents are is this. In a balanced chemical equation, it shows you what you have at the start. That's what your reactants are. And it shows you what you finish with. Okay? Start is your reagent. So what I want you to keep in mind is that when you go into the exam and you see contextual questions that give you like situations like this, you write the equation for whatever chemical you start with. Okay? In this case, you're adding sodium hypochlorite into the pool. Yeah? Sodium hypochlorite is what you're starting off with. You write the equation in terms of the hypochlorite. Sodium's just there, the acidic or basic component is the OCl. Yeah. So you're writing the equation in terms of the OCl. And then this HOCl thing, don't let the question mentioning HOCl confuse you. It happens to be made. Okay? The HOCl happens to be made. Yeah. So that's the first thing to keep in mind. So that's why with this equation they've given you, don't think about flipping it to have this on the left just because they've mentioned this here. Yeah. The acid has been made by this reaction. Okay. So we're going to start off with this. Let's go to the right here. OCl minus aqueous plus H2OL turns into HOCl aqueous plus OH minus. Now, the other thing I want you to keep in mind is this. There's a double arrow here. When we don't know what we're doing with this question yet. Yeah, so I'm giving you sort of the overarching idea first, because if we go straight into it, I'm just going to be regurgitating the steps to you. It's not going to make any sense. Yeah. So I'm sort of painting you the picture first. So that's why we start with this equation. And then number two, because it's a reversible reaction, whatever equation you do, okay, whatever working out you do, we don't know what to do with these numbers yet, but I want to let you know, whatever you do with these numbers, they have to go into an ice table. Yeah. Whatever you do with these numbers, they have to go into an ice table. Now, thinking about that is good because what that triggers your brain to do next is after you realize that these have to go into an ice table, your next job is to figure out where it goes into the ice table. Yeah, because there's a few different spots that you can put these numbers into. Okay, so if we set this up, all right, this is the reaction. Before the reaction has started, all right, you're putting NaOCl into your pool. This is the context, yeah? NaOCl, the OCl is responsible for this reaction. What that means is no OCl, no reaction. Okay, OCl is the reagent for this equation. It starts everything. If there's no OCl, there's no reaction. What that means is if there's no OCl, there's none of this. Yeah? If there's no OCl, the equation can't happen, there's none of this, right? So what that means is this, okay? These numbers that they've given you, this hypochlorous acid, it cannot have been there at the start, right? This hypochlorous acid, the 1.3 by 10 to the minus 4, it cannot have been there at the start. This has to be an equilibrium concentration. The 1.3 by 10 to the minus 4, I'm going to put here. The reason why I'm emphasizing this is, again, what you guys are used to with your basic calculations is you normally get given the concentration of the acid and the base, and then you're normally used to putting that here, yeah? You've never had a question where they give you the information for the product first, okay? And then you'll see in a second, they're actually asking you for the reagent this time. Okay, this is not a question that we're used to. And then the other one is this, pH is maintained by a different buffer, but point is there's pH at 7.5. Yeah. What's the equation for pH? pH is equal to pH is equal to negative log base 10 of what? pH is equal to negative log base 10 of H plus, which we don't have, okay? What do we have instead? We have OH minus, yeah? Does that mean OH minus is 0? No, okay, so pH and pOH are related. Good. So I actually do have a number for OH minus. It's just that they haven't given it to me in an easy format, yeah? So pH is 7.5. That doesn't mean that there's no OH minus. It just means I have to convert to it. So what's the equation to convert between pH and pOH? pH plus pOH is equal to 14, yep. So then pOH is 14 minus pH, which is 14 minus 7.5. What do you get for pOH, please? 6.5. So then the equation for pOH, negative log base 10 OH minus. And guys, if you just rearrange this the way you do in maths class, then OH minus is 10 to the minus 6.5. Okay, so this is the OH minus concentration. Now, guys, what did we say? If there's no OCl minus, is there any OH minus on the right? If there's no OCl minus on the left, can there be any OCl minus on the right? No, because OCl minus is the reactant. Unless it reacts, you don't get any OH minus. So what that means is this OH minus concentration, could it have been there at the start? No, because you didn't have any OCl minus. You need to start the reaction first. So that 10 to the minus 6.5, yeah, 10 to the minus 6.5, where do I put that? In I or in E? Has to be in E, okay? It can't have been there if you didn't have the reagents to begin with. So 10 to the minus 6.5. All right. Now, um, let's start filling the rest of the table in. If you don't have any products at the start, then your initial numbers are going to be 0. All right. And then, ooh, now here's the thing. This is a little bit awkward. What's the change for HOCl? Yeah, it's the plus 1.3 by 10 to the minus 4. Okay. What's the change for OH minus? Yeah, good, Nicole, you picked it up. The change for OH minus is 10 to the minus 6.5. They're different. They're different. Okay. Change is supposed to be according to ratio. All right. What that has to mean, change is according to ratio because of this. Because according to our theory, you're supposed to shift to the right, and then you're supposed to make the same amount of each of them. Yeah, because it's a 1-to-1 ratio, so it's the same amount. If the change isn't the same, they can't have all come from the same place. One more time, okay? If the change isn't the same, they can't all have come from the same place. Because if these got made by the position of equilibrium shifting, you should end up with the same amount, depending on how much it shifts to the right. But that doesn't happen. Yeah. Can you go back to the question for me? Any, it's in this sentence here, the one that I've already highlighted. Good. What gets mentioned here that tells you that one of the two chemicals comes from somewhere else? Good. Guys, good. The pH of the mix of the pool chlorine doesn't just come from the OCl minus. The pH gets maintained by a different buffer at 7.35, by a different buffer. Yeah. So this concentration of OH minus 10 to the minus 6.5 is a mixture of this equilibrium shifting and then whatever the buffer did. Yeah. So what that means is this is the equilibrium number, but I can't fill in the change box because it didn't just come from this reaction, it came from something else as well. Yeah, the something else isn't acknowledged. All we're concerned with is that in this reaction, we know that there's 10 to the minus 6.5. Yeah. The HOCl doesn't come from somewhere else. That doesn't get mentioned here. It just says the HOCl concentration should be 1.3 by 10 to the minus 4. Yeah. Which means the HOCl did come from just this reaction. So I can use the plus 1.3 by 10 to the minus 4. Yeah. Good. So I'm not going to use the 10 to the minus 6.5. I'm going to use the plus 1.3 by 10 to the minus 4. Guys, HOCl is on the right. It's plus 1.3 by 10 to the minus 4. What's the change for OCl minus on the left? Minus 1.3 by 10 to the minus 4. Now, here's the thing though. You've got two things missing. Okay? The change honestly isn't that helpful for me unless I know one of the other boxes. All right? The box that I can leave empty, okay, there has to be a box that I can fill in and the other box is empty. Yeah. Will depend on A, what information I even have in the question. So you can go about it two ways. You can be like, what can I fill in? Or number two, what can't I fill in? Okay. What is the question asking? Good, Nicole, you picked it up. Well done. What is the question? Good. All right. Let's go along with you for now, and then we'll go about the second way after this, yeah? Why can you, so you guys are telling me I can calculate the equilibrium concentration of OCl minus. Why? Good, because equilibrium concentrations can be subbed into the equilibrium expression, and then you can use the equilibrium constant, which they've given for us. For this reaction is 3.33 by 10 to the minus 7, yeah? So the K value, concentration of products, OH minus, concentration of HOCl. And then the reactants, OCl minus, excluding the water because it's a pure liquid, that's meant to equal 3.33 by 10 to the minus 7. So I can fill in the E row because you can only sub in equilibrium concentrations into the equilibrium constant. So I'm looking, guys, I'm solving for OCl minus, yeah, which is actually in the denominator. So be careful when you're rearranging this equation. OCl minus is OH minus HOCl divided by your 3.33 by 10 to the minus 7. So then I sub in the two concentrations I currently have, 10 to the minus 6.5, 1.3 by 10 to the minus 4, divided by 3.33 by 10 to the minus 7. Okay. Now, when you pop this into the equation, the number that you get out of your calculator for OCl minus is about 1.23 by 10 to the minus 4 molar. Okay, so that's going to be what I put into here, 1.23 by 10 to the minus 4. Yeah, which means whatever it started off as, plus whatever the change is, should give you the equilibrium. Yeah, I plus C is going to equal E. Okay. The reason I'm careful with this equation is because you're used to doing I plus C, and then you kind of just add them up. The reason I'm giving you the equation now is because we have to rearrange it. E minus C, okay? 1.23 by 10 to the minus 4 minus 1.3 by 10 to the minus 4. We haven't jotted down everything because there's too many decimals. You need to keep everything in your calculator, yeah? Oh, sorry. It's minus, and then the change is a negative, yeah? So you're subtracting C, but C is a negative value. So just be really careful. So that's going to end up being a plus. Yeah. So your I is going to be 2.53. Yeah, 2.53 by 10 to the minus 4. Okay, so be careful. It's I plus C is equal to E. I is E minus C, but your C is a negative. So when you subtract a negative, it ends up being positive, which is why I looks like a bigger number. Yeah. 2.53 by 10 to the minus 4. Okay. Now, guys, you have two ways of handling this ice table. Yeah. If you didn't realize that you could find the equilibrium concentration, that's okay. There is another way of doing this. Can you read the question for me? What are they asking you to calculate? The amount of sodium hypochlorite that needs to be what? That needs to be added. And what does added imply? Added implies at the start or at the end? Guys, when you're adding something. Yeah, when you're adding something, it goes in at the start. Yeah. When you're adding something, it goes in at the start. Okay, which means they're asking you how much sodium hypochlorite do I need at the start to begin the reaction? Okay, which means you're looking for this box. Okay, that's the box you're looking for. If that's the box you're looking for, the other box needs to be filled. Okay, and that if you when you realize that, that's your trigger to go looking for this afterwards, and then you would have still had to realize you needed the equilibrium expression. Yeah, but that's sort of the way to go. Okay. All right. So this is your initial concentration of OCl minus or NaOCl. It's a 1-to-1 ratio in the pool. Yeah. It's a little bit sus though. Okay. I'm gonna stop here. Do you guys have any ideas where we go from here? I have the concentration of the NaOCl in the pool. Yeah. Now this is really, really awkward. Okay, this is really, really awkward because what you're used to is this. Okay, you're right. You're used to C is equal to N on V. Yeah. So then you're like, oh, V is equal to N on C. But then, guys, my question to you is this. Which concentration are you gonna take? Good, Marin. Good. It's not C is equal to N on V. Okay. What you have here is the concentration in the pool, which is the 1 by 10 to the 4 liter pool. Yeah. What they want is the volume of the 2 molar solution that they need to put in. Okay. So 2 molar volume, which means when you put that 2 molar solution into the pool, into the bigger pool, the concentration gets diluted. That's why this number is so small. Yeah. So the solution gets diluted as it goes in. They want the original volume. So when you use the C1V1 is equal to C2V2 equation, which variable are you solving for? They want the original volume. You're solving for V1 because V2 is the final situation. V2 is the size of the pool, the 1 by 10 to the 4. Yeah, you're solving for V1. Good. V1 is equal to C2V2 on C1. C2 is the final concentration in the pool. It's this one. All right. So 2.53 by 10 to the minus 4. Again, it needs to be everything in your calculator. Molar, the size of the pool, 1.0 by 10 to the 4 liters. Actually, I'm going to write that smaller so you know it's to the power 4. And then C1, the original concentration, 2 molar. Okay. When you pop this in the calculator, you get about 1.267 liters. Yeah, you need to add about 1.3 liters. Oh, how many are we rounding it off to? We are rounding it off to 2 sig figs. The 2 molar original concentration is 2 sig figs. You're subbing in 1.3 liters to 2 sig figs. Yeah. So key takeaway from this question, you don't always have to start with your neutral molecule on the left-hand side. If it's a it is a lot. It is a lot. If these are the kind of questions that you watch out for, yeah? You need to know the bare bone that you need and do not, just because you're doing questions that are very similar to each other, do not trust that pattern, yeah? You start your reactants with whatever is in the question. Okay. And then keep in mind that anytime you don't make the products unless you have the reactants. Okay. So this is a thing to keep in mind. You do not have the products unless you have the reactants to begin with. So anytime you notice them giving you numbers for products, it is not always the initial concentration. It's usually going to be the final concentration in the ice table. You do not have the products unless you have the reagents to begin with. At the start, you only have reagents. So if they give you numbers for products, it has to be the equilibrium concentration. Yeah? Well done.